We are now going to talk about dividing rationals, but we're going to name it something else. Instead of dividing, we're going to talk about what we call rationalizing denominators. And the reason this is important is because we don't want to have to deal with something like what's 1 divided by the square root of 2. And here's why. So let's get our calculator real quick. I'm going to take a square root of 2. And we get 1.414213565237309 ... And it keeps going. So if we keep that in mind, if we were to write this as a long division problem, 141,213 ... And we're going to divide that into 1. So we put our decimal and we add our zeros. And then we're going to say, well, it doesn't go into 1 at all, but it does go into 10. Let's see, how many times? 7 times. And you can see, put it in the right place, 93273,905. And you can see how quickly this gets out of hand because of all of these ... dots, and it just takes so much time. And the reason for this is that our divisor, the square root of 2, is in decimal form a number that never repeats and never stops. It's an irrational number. And because it's irrational, we have to deal with the fact that it's irrational in every step. So what we're going to do is we're going to look at this 1 over the square root of 2, and instead of doing the division now, let's start by saying, well, let's get rid of the radical. So this is what we call rationalizing. Let's get rid of the radical on the bottom in the denominator. So we want it gone. And so there's 2 things we can do, but only one of them is right at this time. We can either square it, because when we square root it goes away, but that doesn't work here, or we can multiply it by something to get it to go away. And the reason we can't square it is because if we square 1 over the square root of 2, that's saying that's the same as 1/2. And notice that 0.7 is much bigger as it goes than the 1/2 or the 0.5. That's what I was trying to get to there. So since it's so big and we can't deal with it the same, we can't just square it. Instead, what we want to do is multiply it by itself. But if I do the same thing on top as I do on bottom, then I'm really multiplying by 1. And when I multiply by 1, I keep the number the same. So 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. And here's my correct answer right here. This is correct, because I no longer have that radical on the bottom. And if I were to do long division now, I put the 2 on the outside, and we put the 1.414213 ... inside, and now we can very quickly get, notice how much faster it is to do now, because I don't have to carry around so many decimal places. I've gotten rid of the decimals in the denominator. So that's why we do it, and that's the basic step. What do I need to multiply by to get rid of the denominator on the bottom? So I want to look at another example with square roots, and then we've got to talk about nth roots. And when we look at this, square root of 3 over square root of 32 looks very straightforward, but I want to break this down. This is 2 and 16. I'm going to stop here because I recognize that 16 is a perfect square, so square root of 16 is 4, and I've rewritten this. Now I want to multiply by the square root of 2 over the square root of 2, because all I need to do is get rid of the radical. I don't need to get rid of the 4. If I do that, then on top I get square root of 6. On bottom I get 4 times 2, which is square root of 6 over 8. Now on occasion you do need to look at this and see, can we simplify? But we don't need to for this problem, simply because we already have inside a radical and outside a radical, and things inside radicals and things outside radicals don't work well together. Since the square root of 6 is simplified, this is our answer. We could have gone the other route, and then the square root of 32, and then times this by the square root of 32 over the square root of 32. We would have gotten the square root of 96 over 32, but 96 breaks down as 3 and 32, and 2 and 16. Well, the 2 and the 16 comes out. It would have left 4 square roots of 6 over 32, and then when we reduce our fractions, this becomes a 1, and this becomes an 8, and our answer is square root of 6 over 8. So I like to always simplify my radicals before I try and clear them.